Okay, so the purpose of this video is I'm going to walk you through our 7.3 through 7.5 quiz review, and then we'll do the quiz online on Thursday. So I'll take you through the first page today, the second page tomorrow, and then the third page we'll complete on Wednesday, and then we'll be well prepared for the quiz on Thursday. So the first section here, we're just reviewing triangle similarity, like what makes two triangles similar, one a miniature version of the other. So we had three tools for this. You could have just angle. As soon as I have two angles in one triangle equal to two angles in the other, we have similar triangles. Or I could have a side angle side situation, or I could have side. That's all I need for similar triangles. Remember, I don't need them to be congruent, just similar. So in the first one here, I don't have angle, but I do see that I have vertical angles here. And then I say I have an isosceles triangle here and isosceles triangle here. So whatever this ratio here is, like, it doesn't really matter if this is 3 and this is 4, or this is 5 and this is 7, then this is also 5 and this is also 7. And that's what I need for the proportional sides. I need the proportions to be the same, and then I have the included angle. So what I have here is side, angle, side situation. So the two triangles are similar to each other. And then I would just want to make sure I list what two triangles are similar to one another. So in this particular case, I have triangle TSR. I want to make sure, a little similar, triangle TSR is going to be similar to WSX. Okay, those are my two triangles that are similar, and they're similar by side, angle, side. Okay, so in the next one, I don't have any angles at all. So what I'm going to need here possibly would be side. So what I need in this case, I need the same proportion to be true from one triangle to the next. So my bigger, it's isosceles again, my bigger sides here are 12, and my bigger sides here are 9. And then my shorter side here is 8, shorter side here is 6. So what I need is for that 12/9 ratio to be equal to 8:6. So what I did, I took the bigger side in the bigger triangle, 12:9, and then the two smaller sides. They have to be the same proportion. If these are all true, and if we simplify these fractions, right, 12 divides by 4 3 times, or divides by 3 4 times, and 9 3 times, so this is 4/3, and if I divide both of these by 2, I get 4/3. So since all the sides are in the same proportion, 4:3, right, 12:9 is the same as 8:6. And if I did 12:8, I would see that I could do it that way as well. If I can show you that. If I wanted to say 12:8, is that the same as 9:6? That's the same idea there, right? We divide, and here I would have 3/2. And this is also, if I divide both of these by 3, also 3/2. Okay? So these two triangles are going to be similar by side. Okay? Okay, so now number 3, we can see I have side, angle, side is possible. But again, so 70 is equal to itself. I have to make sure that that ratio of 10:15, right? So I have the smaller side here, 10, smaller side here, 15. So then we go, sure that's a 10. The larger side over here, 14:21. So if I can simplify both of these fractions and get the same thing. So in the first fraction, if I divide 10 by 5, I get 2. 15 divided by 5 is 3. Here my common factor is 7, right? 7 divided by 2, or 14 divided by 7 is 2. 21 divided by 7 is 3. So both of these reduce to 2/3. It's the same proportion. All sides are proportional. So here we do have side, angle, side similarity. Okay? And now in number 4, what do we have? We have to use a little bit of deduction here, but I have a 90-degree angle and a 60-degree angle. Then over here I have 90 and 30. So I need angle, but if we know that the angles add up to 180 degrees, I know right away this third angle over here must be also 60 degrees, right? 90 plus 30 plus 60 would add up to 180. And likewise, this angle here has to be 30. So I do indeed have the similar triangles. Even though the 60 and 30 aren't the same, their complements would be the same. So these two triangles are similar by angle. Okay, so now we're going to involve a little bit of algebra. So I have similar triangles, and now I want to use the similar triangles to solve for an unknown variable. Okay, so you can see my two triangles here that are similar would be A to B to C, right? Since A has no mark on it, then down here D would be similar to that, D to B to E, right? E and C have to match up, right? A and D have to match up, and B matches up to itself. Okay, so one of the proportions I could set up, I could take, I think this is the easiest one for me to see. I have x plus 1 over 12, right? See how x plus 1 lives between the single hash mark and no hash mark? So he has to match up with x plus 5. He lives between single hash mark and no hash mark, right? So if I set this proportion up, I would have x plus 1 over 12, and then I set that equal to x plus 5. Okay, so I have x plus 1 over 12, right, is going to be equal to x plus 5 over 15. That x plus 5 is down here. So when I cross multiply this, remember this 15 has to be multiplied by both of these. So that's going to give me 15x plus 15. And then we multiply 12. So we have 12x plus 12 times 5, which is 60. Okay? So we're going to subtract and collect all the x's on one side. So if I subtract 12x from here, that goes away, and then I subtract 12x over here, I would just have 3x on the left-hand side. And then what I'd want to do is bring this 15 over. Take him away and take him away here. So 3x is going to be equal to 45. So x equals 15 for that first one. Okay. In my next one, number 6, again, I want to set up a proportion. So I have this x plus 18. We see how he lives along this vertical angle. And so does x minus 3. Furthermore, we've got parallel lines. So we know parallel lines give us alternate interior angles that are congruent. So this angle here, J, is going to be congruent to angle M. So you can see x minus 3 lives between this angle, congruent to angle J. So x plus 18 and x minus 3, they ought to match up together, right? So if I have, if I wanted to take x plus 18, variable expression, over 16, then over here, the x minus 3 has to match up with the x plus 18. So x minus 3 over 4, okay? And again, this is the fun part here. Now is where we cross multiply. So when I multiply here, it's 4 times the whole quantity, x plus 18. So 4 has to multiply by x and by 18. So I have 4x plus 4 times 18 is 72. Okay. And that's going to be equal to 16x. Don't forget the second part, minus 48, right? 16 times x, 16 times minus 3. Okay. And then, of course, we're going to solve. So I would add 48 to both sides, right? 72 plus 48. And then I would subtract 4x from both sides. So if I add 48 here, get rid of it, add 48 here, then I'd want to subtract 4x here and subtract 4x here. So I get 120 equals 12x. So I think we get x equals 10 there. Okay, number 7, I have to be real careful how I set this one up. Since I don't have a value of this side here, I know this is 9 and this is 9. I have parallel lines and they're creating proportional parts. But if the ratio that I set up, and I'm going to need to involve the x plus 5 here. I have to solve for x, so I'm going to have to say x plus 5, yeah, that's a 5, relates to that 6, okay? Now the mistake I know people will make is they're just going to go x plus 5 is the 6, 9 is the 12. Okay? So I have two similar triangles here. I have the small one, EGH, and then I have the big one, E to D to F. Okay? So if we want to do x plus 5 to 6, this side of this triangle to this side, come on back. So I have x plus 5 to 6. I'm fine with that. But that's going to be equal to x plus 14. That's this whole side. Okay? So we have to do x plus 14 to 12. Okay? See the difference between that? So now I can cross multiply, and I would have 12x plus 60 equals 6x plus 84. Okay? And then we can solve that equation. We can subtract 6x from both sides. You know how to go there. So then I'd have 6x equals, if I subtract 6x from both sides, then I'm going to want to subtract 60 from both sides. 24. So I get x equals 4 for that one. Okay, and I'm going to have to do the exact same thing for this last one. I'm going to have to set up x plus 2 lives above the 6. That's fine. But then I have to go the whole entire side here. I need this whole side. So what do I have on that whole side? I've got 3x and x. That's 4x. And then I take plus 2 minus 3. That's going to be minus 1. Okay? So I'm going to have 4x minus 1. The whole entire side is to 14. And then we can cross multiply and solve. So when I do this, I get 14x plus 28. Okay? And I'm going to set that equal to 6 times 4x. That's 24x. And then minus 6. Okay? So if I bring everything to one side, I would add 6 over here, add 6 over here. I think we have 34 on that side. And then I would subtract 14x from both sides. So I get 34 equals 10x. And then we divide by 10, so we get x equals 3.4. Okay, so make sure you go on Unified Classroom and complete part 1 of the 7.3 through 7.5 review. It should be right next to where you found this worksheet.